All right, here's the video called Zero Product Property. And you should have already watched all the videos on factoring polynomials, because now we get to why do we factor polynomials, because we want to know what x equals. And then later on, at the end of this video, I'll tell you why that's important. So the goal of this video is afterwards you'll be able to solve for a variable using factoring and the zero product property. Let's start with something very simple. What does x equal? Well, if you wanted to show your work, you would just subtract 4 from both sides, and you would have x equals -4. Or you could just look at it and say, what plus 4 equals 0? Well, it must be its opposite, -4. Here, what would x equal? Well, again, if you show the long work, you can divide both sides by 5 to get rid of this 5. And x equals, well, 0 divided by 5 is 0. Or you could have just asked yourself 5 times what equals 0, and that would have been a 0. Okay, what does x equal? There's 2 x's. Should I distribute? No. So what does it equal? Well, that's where this zero product property comes into play. The zero product property states that if there is a product of factors, in other words, a multiplication problem, on one side and a 0 on the other side of the equation, then at least one of those factors must equal 0. So here's an example. If I have x times y equals 0, then either the x must equal 0 or the y must equal 0, or they both must equal 0. Let's use the zero product property for this problem. First of all, I have 2 factors, x and x minus 6, and I'm just going to split them off and make them both equal 0. So x equals 0, well, that one's done. And then x minus 6 equals 0. Well, what minus 6 equals 0? 6. And so basically, I have 2 answers, 0 or 6. And you can throw it back into the problem and try this out. What if x equals 0? Then I would put a 0 everywhere that I see an x. And I would have 0 times -6, which equals 0. So that proves that the 0 works. Or I can put the 6 in for that, and I can say that, and again, I'm going to put the 6 in wherever I see x, and that's going to be 6 times 0, which also equals 0. So my 2 answers are either x equals 0 or x equals 6. Okay, let's do it again. I'm going to have a 3x that equals 0, and I'm going to have an x plus 5 that equals 0. And so what times 3 is 0? 0. In fact, anytime you have a monomial, your answer is going to be 0 for that letter. And then what's the opposite of positive 5? -5. And there you go. That is the answer to this problem. Students actually tend to find this one easier because you don't have something hanging on the outside of a parentheses. So in this case, what would x have to equal to make this binomial 0? Well, 7. And what would x have to equal to make this binomial 0? A -4. And that's my answer. And again, it's very important that before you start solving for x, that this side has to have a 0. Pause the video and tell me what x equals here. All right. If there are 3 binomials, x has 3 answers. And so in this case, x is going to equal either a 1, a -2, or a 3. Did you get that? What about this one? Well, this is only going to have one answer. You have one binomial. And I know it says squared, but it'd be the same number in both. And so what minus 5 is 0? 5. And that's your answer. X equals 5. So in this case, you have just one answer. This can get a little tricky until you see a trick. So I'm going to start with this. It's going to be 2x minus 7 equals 0, or 2x plus 7 equals 0. And I'm going to solve this 2-step equation here. 2x equals 7 divided by 2 divided by 2. So x equals 7 over 2. And over here is can basically be the same thing, except it looks like my 7 is going to be negative. Divided by 2. And then I get x equals -7/2. Now, those are your 2 answers. I want you to start looking at the pattern between the answers and the binomials. And that's where the trick comes in. I'm going to just show you this once. What number here, this number here, does it have to be positive or negative to get that 0? It has to be positive. So that tells me that I'm going to have a positive. And then check this out. The second number, I'm going to use another color here. The second number here becomes my numerator. And the first number here in front of the x becomes my denominator. Huh. All right, let's show it to you one more time. Look at the next one. What does this have to be? This term has to be what? Positive or negative for that 7 to go away? It has to be negative to be opposite of the positive 7. And so hence we have the negative right there. My second number here becomes my numerator. My number with x becomes my denominator. And that's the trick. Now, if you don't know the trick, that's okay. Solve the two-step equation. Can you solve this? No. This is why we need to factor. And so this is an easy one because the a value is a 1. So I know I have x and x. What factors of 28 are going to subtract to become a 3? Well, that's a 7 and a 4. And since the 3 is negative, I'm going to have a negative 7 and a positive 4 equals 0. Oh, this is easy now. X is either going to equal 7 or x is going to equal negative 4. So to solve these, you must make sure that not only do they end with a 0, but you also need to factor. All right, look at this one. It's not as hard as it looks. In fact, I don't have to make it into two binomials because it's already just a binomial. But what I am going to do is I'm going to divide out the greatest common factor, which is a 4. It looks like the most x's I can pull out is 3 of them. So I'm going to have a 4x to the power of 3. And then what's left over is x plus 6. Oh, this gets really simple. And so I'm just going to, instead of writing it out, I'm just going to pull it over here. If I have a monomial, then x is going to equal 0. And in this case, x is going to equal the opposite positive 6, which is negative 6. And there's my answer. What do you think you're going to do here? Well, this is where it's very important for you to remember that one side has to equal 0, and I don't have a 0 on either side. So I'm going to go look for my leading coefficient, and since my 4 is positive, I'm going to leave that over there. I'm going to move the 28r to the other side. So I'm just going to say do the opposite, plus 28r. Remember, they're not like terms, so I can't put them together. And I'm going to have 0 equals 4r squared plus 28r. All right, the next step is to find the greatest common factor, just like we did in the one before, and they both can be divided by a 4. So I'm going to pull the 4 out, oh, and an r. And then inside, I'm going to have an r plus a 7. Okay, now I can solve. And again, if it's a monomial, then the r is just going to equal 0. And then in this case, I'm going to put a little or, r equals negative 7. So why do I even care about solving for x? What does that get me? Well, this is the beginning of a topic called solving quadratics. And if you remember, quadratic is just basically something with the highest degree of 2, which is what we are looking at right here. And when I solve for quadratics, it helps me to graph the quadratic, which you see the graph here. A graph of quadratic is a parabola. That's what you see, that little U right there. And I'm going to go ahead and factor this because that's what I have to do to solve for x. So let's see. The factors of 36 that add up to 15 are 12 and 3, but they both have to be negative. All right, if I'm going to solve, then this one, x is going to equal 12. And then x is going to equal 3. And now let's look at the graph for this equation. Actually, we would call this a function if it's a graph. And where does it hit the x line? At the 3 and at the 12. Isn't that coincidental? It's actually not a coincidence at all. So why do I care about solving for x? Because it's going to help me later on graph these parabolas. All right. Thankfully, right now, you don't have to graph the parabolas, but I want you to go practice the zero product property. Go have some fun.